Hi. Hello everyone. Welcome to information sharing session on failure analysis. Casting defects are rarely unintentional. They happen when certain processes in the manufacturing process aren't properly managed. A defect might be caused by a single, well-defined source or, more commonly, by a mix of causes. Only the most prevalent faults are selected for characterization among the various problems commonly encountered during traditional casting methods such as sand casting, die casting, and investment casting. Shrinkage in casting. Solidification shrinkage occurs as metal transitions from a liquid to a solid, while thermal contraction occurs as it cools to room temperature. Shrinkage in the foundry necessitates careful planning in the pattern and molding design. As a result, shrinkage allowances are built into the design of cast parts to ensure that the desired dimensions are achieved. Shrinkage tolerances for various metals are known, and an expert mold designer will account for shrinkage while creating a mold. Shrinkage can produce defects in cast products, resulting in failure, leakage, and other issues. These faults can sometimes be seen on the casting's surface and can be discovered visually or via dye penetrance or other non-destructive methods. Internal casting defects are sometimes difficult to detect and require X-ray inspection or destructive testing. The term, open and closed shrinkage flaws, refers to both types of problems. Open shrinkage defect. Pipes may form in the surface and extend into the body of the casting if the metal cools and shrinks without enough liquid to fill any holes. Cave flaws, also known as sinks, are imperfections that start on the surface and propagate across the face. In both cases, the faults are exposed to the atmosphere, and air replaces the molten metal. Cracks and hot tears typically appear during the final phases of solidification and can be confined around abrupt changes in stress concentration, such as a thin web linking two heavy parts. They can also happen when there isn't enough draught in the portion or when heat pools in heavier sections. Closed shrinkage defects. Closed shrinkage flaws, also known as shrinkage porosity, are imperfections that arise within the casting. Hot spots are formed when isolated pools of liquid form inside hardened metal. The shrinkage defect usually appears at the top of the hot spots. They require a nucleation point, thus contaminants and dissolved gas can cause closed shrinkage flaws. The faults are divided into macroporosity and microporosity, or micro-shrinkage, with macroporosity visible to the naked eye and microporosity not. Causes of shrinkage defect. There are numerous causes of shrinkage defects, including insufficient metal feed, isolated heavy portions, and sudden sectional changes. Failure to achieve desirable heat centers, such as risers or ingates, in terms of directional solidification. Mold enlargement as a result of soft or uneven ramming. An inappropriate metal composition, such as one with a lot of phosphorus or little carbon equivalent. Extreme pouring temperature. Gas defects. Blowholes, surface or subsurface pinholes, intergranular porosity, and other gas defects are frequently seen in castings and are brought on by the creation, buildup, or entrapment air or gas. The riser of the runner top is where gas holes typically appear. Causes of gas defects. Gas defects are typically caused by the sand mixture contains a large amount of moisture, fume, carbonaceous, and gas-producing material, and has poor permeability and grain size distribution. Molds that are not consistently rammed, hard to ram, and insufficiently ventilated. Cores that are poorly permeable, hard, unbaked, and improperly ventilated, as well as overly wet or thick core paste. Ladles that are cold and moist, slow and interrupted pouring, gassy metal, loud stirring, overheating, etc. Using chills and wires that are rusted, inadequately coated, oxidized, and wet. Pinholes. Gas porosity is a type of pinhole defect. They are often small, elongated holes at, or immediately below the casting surface, with the pinhole's long axis perpendicular to the casting surface. Steel pinhole walls are frequently smooth and shiny. When the pinholes extend to the casting's surface, the inside may appear oxidized with a slight dendritic structure. Pinholes can form on or below any casting surface, however they are more common in thin and intermediate transition thicknesses, where reentrant angles can act as hot spots. Pinholes are mostly formed by hydrogen evolution during solidification. Pinholes are also produced by molds with high moisture content, gas-generating components, and metal mold reactions. Improper degassing also contributes to gas porosity. Causes of pinhole defects. The following frequently results in pinhole defects. Too much nitrogen in the melt as a result of the charge composition. The charge materials contain an excessive amount of oxides, hydroxides, rust, and other contaminants. An excessive amount of aluminium in the melt. The melt's manganese and sulfur level is excessive. An excessive amount of nitrogen in the sand. An excessive amount of moisture in the sand. The molding sand produces too little lustrous carbon. The core sand has a very high nitrogen content. Too much nitrogen and hydrogen is present in the core binder. Using too extended passages. There was excessive swirling and slag buildup during pouring. Misran. When the metal fails to completely fill the mold cavity, a misran or short run results from a lack of process completion. The failure of two metal liquid streams flowing in separate directions to combine causes cold shut, which leaves crack-like indications with smooth rounded edges. Causes of misran. The following are the causes of these flaws. The metal's insufficient fluidity. The pouring temperature is low. Interrupted pouring, incorrect gate, runner, and sprue sizing, and sections that are thin. In coming sessions, we will go through few more casting defects. Thank you.